Hi everyone, this is Mr. Cardoso, and in this video we are continuing our lesson on the introduction to objects. In this particular lesson we're going to be talking about class fields. In the last lesson we talked about class methods. Here we're going to be talking about class fields as opposed to instance fields. So first of all, what are instance fields? So here we've got our instance fields for our fraction class that we've been using throughout this example. Our numerator and our denominator, both of type integers. And they're instance fields because each instance of the fraction class will have their own version of a numerator and denominator, as we have here in these diagrams as we have here. So for example, I can come here to the interactions panel, which again, it's like using another class. It's like writing the code over here in the fraction calculator class, or I can use the interactions panel. So I can say fraction f1 equals new fraction, and as in our diagram for f1 we have 3 and 7, and then I can do fraction f2, and I can go 5 and 3 for the second one, and I just kind of chose those numbers randomly. So we've got our two fractions f1 and f2 as you see there. So each fraction, the 3 goes into the numerator and the 7 goes into the den field over here. So we can see our num and our den field here in our diagrams. And for f2, 5 and 3 go into the num and den field respectively for that fraction. So we see we have two instances of the fraction class here, f1 and f2, and they have their own versions of the instance fields, 3 and 7, and f5 and 3 for the other one. So those are instance fields. So what are class fields then? And class fields kind of like are like global variables, just the same, right? So what we're going to do with class fields, and if you remember, what was that keyword we used for class methods? If you remember, class methods had a special keyword, and if you recall, that keyword is static. So we're going to go ahead and use that keyword here, static, for class fields. So these are instance fields, so I should put another comment here saying class fields. So we can say, for example, static, and let's say int num of decimals. Okay, so what this does now is, what does this keyword static do? Well, because we have static there, that means that this variable is now common amongst all instances. So whereas each instance has its own version of a numerator and denominator, the num of decimals field is common. So there's only one of these. So it doesn't matter even if I have f3 created here or f4, and I have a whole bunch of these fraction objects, right? It doesn't matter if I have thousands of these fraction objects. There is only one num of decimals field, and we can represent that here, with a little box, okay, and its current value. So we made it an integer. It doesn't have to be an integer. And why number of decimals? So I was trying to think for this example, what's a good example for something that would not be particular to a specific instance. So I thought, what about number of decimals? Because number of decimals could be common. So no matter what you're working with in the class, whatever fraction you're working with, you might want to set the number of decimals to a certain number of decimals, and then you want all your fractions to be, say, rounded. If you were to use the 2 decimal, where's our 2 decimal method? We always lose it down here. Well, that's our class method. Do we have our other one? Yeah, right here. So let me just move this to the top so it's easier to find. Put that right here. So we've got our 2 decimal version, which returns the decimal of the fraction. So for example, 3 over 5 would return 0.6 and so on. So what if we wanted this to work based on our number of decimals field, but we wanted it to be the same for all of the fractions? We could take out the keyword static here and then set the number of decimal places for each fraction separately. So for example, F1 could be set to 2 decimal places, F2 could be set to 5 decimal places, and so on. But because I'm trying to teach you about class fields, I made it static for this example. So it depends what you want to do in your program. So where could we set the number of decimals? You could set it in your constructor, for example. So that was one place where you could ask the user to set the number of decimal places. You could also give it a default value at the top so as not to put it in the constructor, so that the user doesn't have to now create a fraction thinking about the number of decimals for all their fractions. So we can set the number of decimals to, let's say, 3 decimal places by default. And the user can, of course, change that. So let's take a look at this. Now let's just compile and see this example through. So what we've done here is we've set the number of decimals to 3 here by default. And the secondary programmer can change this because this is not private, right? It doesn't have the keyword private, so they can access it directly. So how do you access it? So first let's go ahead and create our 2 fractions again. Okay, so now I'm going to try to access this field. So if I go F1, for example, I can change f1.num to, say, 17, right? We know we can do that. Can I say f1.num of decimals gets, let's say, 5? That works as well. So now we've changed f1.num of decimals, but this is not an instance field, so it doesn't belong to f1. So how come I can use f1 as the handle to access it? Well, it's one of those things where Java just gives you some flexibility on that. So yes, you can use f1 to change the number of decimals to 5. So now this in our diagram, whoa. What's going on here? So this in our diagram will change to 5. Okay, but all of these instances share that same variable because it has the word static in it. It means it's a class field. It means it's shared amongst all of the different instances of that class. So that means if I go, well, what's f2.num of decimals? And you'll also get 5. So if I go f2.num of decimals gets 18, and I go, well, what's f1.num of decimals? Hey, it's also 18. So they're all sharing the same, even though f1 and f2 are not the same instance. Okay, we did an example like that before where we copied, the handle of f1 into f2. That's totally different, right? f1 and f2 are completely separate instances. They are not the same instance. But they're sharing. So if I still say f1.num, for example, I get 17. If I go f2.num, pull that up into the screen, I get 5. So they're not the same instance. They're still pointing at different objects. But f1.num of decimals and f2.num of decimals are both the same. And that's because it's a static class field, okay, which is shared amongst all instances. Hope that makes sense. Now, better programming style to access the num of decimals field or to change it would be to use the class name because it's a class field. So it's best practice when using class fields to use the class name to change them, because that's really what you're doing. You're changing it for all of your fractions or all of your instances. So if I say fraction.num of decimals gets 5, or let's say 1 now. Now again, for f1.num of decimals, it'll be 1. And for f2.num of decimals, it'll be 1 as well. And so, this diagram changes over here to 1 because it's shared amongst all. Right? So when would these class fields be useful? Sorry, this one right here. This class fields would be useful. And that's why in certain circumstances, you want to think, well, what's that one variable that you want to have, but it's common to all of the instances. So if you change it, it changes for all of the instances. So another example, with a fraction class, it's kind of hard to come up with an example, but let's say, for example, you were making a car. So you could say class car, and you could have, int num of doors. These are instance fields. You can have string color for the car. Let's say int horsepower, which is the power of the car, how strong the engine is, and so on. Int or double engine size. So these are instance fields because every car that you make will have different number of doors. Maybe you'll have a 2-door car, a 4-door car. You'll have a different color. You have a different amount of horsepower, different engine size. There could be lots of things you can add for a car depending on what you're making this car object for. But then you might do something like this. You might say static double gas price. And that's because, why would we make gas price static? Well, we'd make gas price static because it can change, it's a variable, right? So it can change throughout time, and the user can change it. Gas prices go up every day, and the gas price goes up and down every day. But when it goes up and down every day, it changes for every single car, right? So if gas is 95 cents today, it's 95 cents no matter what car you drive. So I shouldn't have to change that. That's not something that belongs to each instance. That's something that's common amongst all of the instances. So that might be a place where you would use static. Now, if you also wanted to make it so that they couldn't change it, like it's set at the beginning, then you would have to set it up here, to 96.5, I think the gas price was today's. So if you wanted to set it to something like that, and then you don't want it to be variable, which is not the good example for this gas price, because gas price is variable, it changes all the time. Then you could use the keyword final. Okay, so if you use the keywords final, then that makes it a constant. And if you're making it a constant, then it should be all caps. And if you have more than one word, you should use an underscore. So constants are all capital letters for their variable names or identifier names. If it's not constant, then you name it just like before. And you can, or you don't have to set the initial value. So you can do this, or you don't have to. You can set it in a constructor, or you can change the user because it's not private. The user can change it. Or if you make it private, then that's something different, because then you can add mutator and accessor methods for the user to change it. So that's a good example of something that might be shared amongst all instances of cars, whereas these things, each instance has its own version. So going back to the fraction example, where could we use the number of decimals as 3? Well, we probably, maybe if we had more methods, we could use it more, but we probably want to use that here. If we want to round to the number of decimals that's given by the class field, the user can change it. The secondary programmer can change it. So here, we probably want to change this up to round to the number of decimal places that's given by that field. So you can do some math here to say if this is 3, you can then round this to 3 decimal places and then return the decimal version. If it was 5, you could round it to 5 decimal places. If it was 2, you could round it to 2 decimal places. But whatever you change this to, anytime you're using this method, it would use that value, And so for all of your fractions, it would